Hey everyone, it's Mrs. Nash here, and we just want to review some things about right triangle trig. Specifically, we want to talk about the sine, cosine, and tangent functions in right triangle trigonometry. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent, I don't know why I wrote tangent is equal to opposite over adjacent. But in order to use those functions, you're going to have to know what opposite, hypotenuse, adjacent means. So if I put an angle right here, then I think about the opposite side as being the one that's across from, or on the opposite side of the triangle. The one that has a side that touches it or is right next to it is adjacent, which is what adjacent means. And then the one that is across from the 90 degrees is the hypotenuse. And in order to solve these three equations, you have to just put the angle in with a function and then make a ratio of the opposite sides of the hypotenuse for sine, adjacent over hypotenuse for cosine, and opposite over adjacent for tangent. So let's just say that we had, let's see here if I can erase, no, let's just try again. If I had this angle, let's say this angle right in here was maybe 30 degrees, and I wanted to know how big the opposite side was, and I knew that the hypotenuse was 12, and we'll just leave labels out for now. We'll just pass on that. So I look at my angle and I say, well, I have the opposite side being in question, and I'm given the hypotenuse. I don't really care about adjacent, so I need to look at this and say, well, I need a formula that has opposite and hypotenuse in it. So I look at sine. So my equation would set up sine of 30 degrees equals the opposite side over the hypotenuse, which in this case would be 12. So we don't know the opposite side, so we're going to make that x, and the hypotenuse would be 12. So overall we'd have sine of 30 equals x over 12. So in order to solve for x, just like I would do in algebra, I would multiply both sides by 12, canceling that. So then x would equal sine of 30 times 12. So sine of 30 times 12 is 6. So the opposite side is 6, and you can do that on your calculator. Just hit sine of 30. Depends on what type of calculator you have, but you can usually just type that in just in order like that, and then times 12, and you're going to get 6. And so this side over here is equal to 6. This is 12, this is 6 for a 30-degree angle. Let's do one more. See if I can erase this. Let's do one more. And let's say we have different parts this time. Let's say that we have this angle in here, and let's say that this angle this time is maybe 40 degrees, and we have this side is 100. They can really be any kind of value for a number, small or large. It's really just a ratio situation. So now let's say I don't know this side. So this is the side that's in question. I have this side. So I look at this and I say, well, this is compared to the angle. This is across from. So this is the opposite side. This one is right next to. So this is the adjacent side. And if I looked at this right triangle right here, and I went across from that, this one would be the hypotenuse. So the thing we have is the adjacent side, and the side that's in question is the opposite. So I need to look for a formula that has adjacent and opposite, and adjacent and opposite would be tangent. So tangent of 40 degrees is equal to the opposite side, which we do not know, over the adjacent side, which is 100. So there we have it. So we're going to do 100 times both sides. So I would take 100 times the tangent of 40. Just type it in my calculator. And I calculate that to be 83.9 or 84. So the opposite side, when I multiply that out, is equal to 84. So 84 equals the opposite side. Now we'll pay attention to whether these are y. If we're talking about the xy axis, the vertical ones are usually y, the horizontal ones are usually x-axis, but we'll go over that at some other time. But basically, that's the setup. Adjacent is next to the angle, like this, and opposite is across from. So that is a review of right triangle trig.